Very good morning, students. Welcome to the chemistry session. So far, we have completed up to double displacement reactions in this lesson. Am I right? Yes. So, in this session, we are going to discuss about the observations in detail when we carry out all these reactions in a laboratory. Yes. So first we are going to start with combination reaction. So in combination reaction, we are going to discuss about the observations which happens during the burning of magnesium ribbon. And we all know the equation 2 Mg plus O2 gives 2 MgO. What do you mean by this? Magnesium burns in oxygen to form magnesium oxide. Let us see the experiment. Here we have taken a small piece of magnesium ribbon which is cut from a roll of magnesium ribbon. This is Bunsen burner, watch glass and a pair of tongs. Let us see what happens when magnesium burns in the presence of oxygen. A small piece of magnesium ribbon is taken and with the help of tongs, it is burnt by using the Bunsen flame. See here, the magnesium ribbon burns with the dazzling white light. Yes, with the bright dazzling white light it burns and it forms a white powdery mass of magnesium oxide which we can collect it in the watch glass. So this powder is nothing but magnesium oxide which is formed as a result of burning of magnesium ribbon. So this is an example for combination reaction. Yes. Now second is double displacement reaction. For that we are taking potassium iodide in a conical flask and then lead nitrate in another conical flask. Now water is added to both the conical flasks to get the solutions of lead nitrate as well as potassium iodide. So we are making solutions. This is lead nitrate solution. And this is potassium iodide solution. Now, when we mix both the solutions, we get an yellow precipitate of lead iodide. Can you see? Yes, a bright yellow precipitate. Now, we are going to see a demo for displacement reaction happens between metal and acid. For that, we have taken zinc metal and dilute hydrochloric acid. So, these zinc granules are taken and it is dropped in a boiling tube. Now, to this zinc granules, we are going to add dilute hydrochloric acid in drops by using dropper. Now, this is the reaction happens. See, clearly we could see the formation of bubbles due to the liberation of hydrogen gas. So, zinc reacts with hydrochloric acid to form zinc chloride and liberates hydrogen gas. This hydrogen gas will put off the burning splinter and gives a pop sound.
Yes.
So, this is an example for displacement reaction. Next, we are going to see combination reaction, namely calcium oxide, that is quicklime we have taken. So, dissolution of quicklime in water, that is what the reaction we are going to see. Yes. So, we all know when we dissolve calcium oxide in water, it forms calcium hydroxide. And of course, this reaction is an exothermic reaction. See, this is nothing but calcium oxide, which is also known as quicklime, which is a white powder, and it is taken in a beaker. Now, water is added to this calcium oxide. Now we can feel the hardness when we touch the outside of the walls of the beaker. Yes. So now the calcium oxide has formed calcium hydroxide, which is a base. How can we say the calcium hydroxide is a base? We can test it with the help of red litmus paper. If a solution is a base, it will turn the red litmus into blue. Yes. So, when we soak the red litmus paper inside this beaker, we get the color change from red to blue. So, we could understand that calcium hydroxide, which is a base, which is formed as a result of dissolving calcium oxide in water. Of course, we could feel the hardness because this reaction is a highly exothermic reaction. Yes. So now we could see the equation. Yes. Now we are going to perform thermal decomposition reaction. Here we are taking ferrous sulfate crystals. These crystals are pale green in color. What happens when we heat? Pale green color crystals of ferrous sulfate changes into brown because of the formation of ferric oxide, and we could get the smell of burning smell of sulfur because of the liberation of sulfur dioxide gas. 2FeSO4 gives Fe2O3 plus SO2 plus SO3. Now, we will see the thermal decomposition of lead nitrate. Yes. So lead nitrate salt we have taken, Bunsen flame, test tube which contains lead nitrate, and of course this lead nitrate salt is white. And this is incense stick which help us to find the liberation of oxygen gas. So lead nitrate on heating gives lead oxide, nitrogen dioxide which is a brown gas, and then oxygen gas. Let us see the observations. See here, we are heating the lead nitrate salt. Little by little, the decomposition reaction occurs, and we get the evolution of nitrogen dioxide gas which is brown in color. See, clearly we could see the liberation of brown color gas which is nothing but nitrogen dioxide. And when we insert this incense stick, it burns brightly because of the liberation of oxygen gas. Why? Because we all know oxygen is a supporter of combustion. So when we insert a burning stick, it will burn brightly. Clear, dear? Yes. So in this experiment, two types of gases are liberating. One is nitrogen dioxide and another one is oxygen. Now, double displacement reaction we are going to see with sodium sulfate and barium chloride. So first we have to prepare solutions of barium chloride and sodium sulfate by dissolving them in water in separate containers. When we intermix both the solutions in a test tube, what happens? Let us see. So first barium chloride is taken in one test tube and sodium sulfate in the another test tube. So both are aqueous solutions. When they are mixed together, what happens? They form a white precipitate of barium sulfate. See here. Isn't it? First the solution was transparent. Now it forms the appearance of turbidity, isn't it? Yes, because of the double displacement reaction happens between sodium sulfate and barium chloride. The precipitate formed here is nothing but barium sulfate, which is a white solid. Shall we recall the equations of the experiments? Yes. First one, combination reaction which happens between magnesium ribbon and oxygen. So 2 Mg plus O2 gives 2 MgO. Yes. What is the second one we have seen? Double displacement reaction which happens between Lead nitrate and potassium iodide. Lead nitrate and potassium iodide. What is the formula of lead nitrate? PbNO3 twice. What is the formula for potassium iodide? Ki. And both we have taken as aqueous solutions. And they combine together. Exchange of ions happens to form what? Lead iodide, Pbi2. And then potassium nitrate, KNO3. Here potassium nitrate is obtained as an aqueous solution and lead iodide is nothing but the precipitate. And the color of the precipitate is yellow. Right. So for balancing, what should we do? We should write 2 KNO3. Here 2 Ki. That's it. The name of the precipitate formed is lead iodide, formula Pbi2, and the color is yellow. And this is an example for double displacement reaction. Yes. And third example, zinc with dilute hydrochloric acid. Yes. Zinc reacts with hydrochloric acid to form a salt called zinc chloride and it liberates hydrogen gas. Zinc is a solid. Hydrochloric acid we have taken as an aqueous solution and zinc chloride salt is obtained as an aqueous solution and hydrogen is evolved out as a gas. I can use upward arrow mark or else I can write the symbol G. Isn't it? Yes. And this reaction is an example for what reaction, ma? Displacement reaction. Yes, of course. Why? Here the metal zinc is highly reactive which displaces hydrogen from the hydrochloric acid. Yes, of course. So here one is a metal, another one is a non-metal. Okay, dear? Yes. So zinc is a highly reactive element which displaces the hydrogen which is comparatively a less reactive element. So displacement happens, as a result we get zinc chloride. Clear? Right. Next example. What we have seen? The dissolution of calcium oxide in water to form calcium hydroxide. And of course, this is also an exothermic reaction. So we could say this is an example for combination as well as exothermic reaction. And where do we use it? In the whitewashing of walls. Right. Next equation. For the thermal decomposition of ferrous sulfate. Ferrous sulfate on heating gives ferric oxide Fe2O3, sulfur dioxide SO2 and sulfur trioxide SO3. For balancing we should write 2FeSO4 on heating gives Fe2O3 plus SO2 plus SO3. And let us write the physical states. Ferrous sulfate is a solid and ferric oxide is a solid. Sulfur dioxide as well as sulfur trioxide are gases. Here sulfur dioxide you can identify by the burning smell of sulfur or else rotten egg smell. Yes. And of course this is nothing but what type, ma? Thermal decomposition reaction. For the previous equation also we can write the physical states. Calcium oxide is a solid, water is a liquid. Of course, calcium hydroxide is an aqueous solution. Yes. So, next what example we have seen? The thermal decomposition of lead nitrate. Lead nitrate formula PbNO3 twice. On heating, it gives PbO, that is lead oxide, and it liberates a gas, namely nitrogen dioxide, and another gas called oxygen. Yes. So for balancing, we should write 2PbNO3 twice gives 2PbO plus 4NO2 plus O2. Here we have seen this lead nitrate is a white solid which turns into brown by heating due to the formation of lead oxide. And of course, this nitrogen dioxide is also a brown color gas. And the evolution of oxygen gas in this reaction can be identified by bringing a burning splinter near the mouth of the test tube in which we carry out the experiment, right? What happens to the burning splinter? It burns very brightly because oxygen is a supporter of combustion. Yes. Last and final example we have seen, namely double displacement reaction of barium chloride and then sodium sulfate. Barium chloride formula BaCl2, sodium sulfate formula Na2SO4. Of course, both are taken as aqueous solutions, and when we mix them together, we get what? A solid product, namely precipitate, and the name of the precipitate is barium sulfate. Along with that, we get sodium chloride aqueous solution. Yes. So for balancing, I have written 2 before NaCl. Right. Now, we will see about oxidation and reduction reactions. Just now we have completed seeing the burning of magnesium ribbon. Am I right? Yes. What is the equation? 2Mg plus O2 gives 2MgO. Yes. And this reaction is a combustion reaction. What do you mean by combustion? Burning. Yes, burning in the presence of oxygen is called combustion. So this is an example for combustion reaction. And then what is the type we can say? This is combination reaction because two reactants combine together to form a single product. So this is an example for combination reaction. And one another thing we can say it as oxidation. Oxidation. Why? Because here oxygen is getting added with magnesium. So this is an example for oxidation also. So this burning of magnesium ribbon we can call it as combustion reaction, combination reaction or oxidation reaction. Yes. Now let us see the various definitions for oxidation and reduction reactions. Yes. First, oxidation reaction and reduction reaction. Yes, let us see the various definitions. First one, addition of oxygen is called oxidation. What do you mean by oxidation, ma? Addition of oxygen. Yes, what do you mean by oxidation? Addition of oxygen. Yes, then what do you mean by reduction? Addition of hydrogen. Addition of hydrogen. Second definition. Removal of hydrogen is called oxidation. Here, removal of oxygen is called reduction. And then, loss of electrons. Loss of electrons is called oxidation. Gain of electrons is called reduction. Last and final definition. When oxidation number increases, it is called oxidation. When oxidation number decreases, it is called reduction. If we see specific example, it will be very clear for you. For example, oxidation is nothing but addition of oxygen. Just now we saw example, Mg plus O2 gives MgO. Or else we can say C plus O2 gives CO2. Here oxygen is getting added with the carbon. So this is an example for oxidation, right? And then second definition what? Removal of hydrogen. Yes. For example, ammonia. NH3 means what dear? Ammonia decomposes to form nitrogen gas and hydrogen gas. And for balancing we should write 2NH3 gives N2 plus 3H2. Okay. So this is also oxidation. Why? Because we have removed hydrogen. Okay dear? Yes. From ammonia, hydrogen is getting removed. So this is an example for oxidation. And then loss of electrons. Loss of electrons is called oxidation. Yes. What example we can say? Sodium loses electron to form sodium positive ion. Sodium actually atomic number 11. 11 proton, 11 electron, that is 11 positive charge, 11 negative charge. So when one electron is removed, it will become namely 11 proton but 10 electron. Am I right? When we remove one electron, it will become 10 electron and 11 proton. So this is not an atom, it becomes an ion. And which charge is greater? Either positive or negative? Positive is greater. So greater by how much units? 1 unit. So we should write it as Na plus ion. Am I right? Yes. This and all already we have studied in 9th standard itself. Yes. So sodium loses 1 electron to become sodium positive ion. This is an example for oxidation. Why? Because loss of electron is called oxidation. And last concept also we can see. Oxidation number increases is called oxidation. How can you agree? See, the same example we can have. See here, sodium, when we write as Na, there is no symbol, there is no charge. So it is a neutral atom. So the charge is 0. Oxidation number is 0. Oxidation number is 0. Yes. And what about Na plus? The charge is plus 1. So the oxidation number is plus 1. So what happened to the oxidation number? Oxidation number changes from 0 to plus 1. It is nothing but increase in oxidation number. So increase in oxidation number is called oxidation. Yes. Now we will see the examples for reduction. What do you mean by reduction? Addition of hydrogen is called reduction. We can say N2 plus 3H2 gives 2NH3. That is formation of ammonia from nitrogen gas and hydrogen gas. This is an example for reduction. Why? Because addition of hydrogen happens. Right. And then second definition, what do we discussed? Yes. Removal of oxygen. Removal of oxygen is called namely reduction. Yes. You have to look at this part of the reaction alone. Two parts are there in this reaction. So this part alone you look at. Zn-O. What do you mean by Zn-O? We all know Zn means zinc. Zinc oxide. Right. And what is Zn? Zinc metal. Right. So zinc oxide loses oxygen and becomes zinc. So here oxygen is removed from zinc oxide. So this is an example for reduction. Okay, first one addition of hydrogen, second one removal of oxygen, right? Next one, electron concept of reduction. What do you mean by electron concept? Yes. Here, loss of electron, we said oxidation. Loss of electron, oxidation, yes. So what do you mean by reduction? Gain of electrons. Gain of electron is known as reduction. Example, chlorine gains an electron to become Cl minus, that is chloride ion. Chlorine atom gains one electron to become chloride ion. This is an example for reduction reaction. Okay ma'am? Yes. Here chlorine atomic number 17, 17 protons and 17 electrons, that is positive charge and negative charge. So when we add one more electron, proton will not get changed, but electron would become 18. Am I right? So which charge is greater, either positive or negative? Negative is greater, and greater by how much units? 1 unit. So we should write it as Cl minus ion. So the formation of chloride ion from chlorine atom, it is an example for reduction reaction. And the same we can quote for reduction, namely in the oxidation number concept. How ma? See, chlorine atom, actually the oxidation number is 0 because it is a neutral atom. When it gains electron, it becomes Cl minus, so the oxidation number is minus 1. So oxidation number changes from 0 to minus 1, which is nothing but decrease in oxidation number. So it is an example for reduction. Yes. So for oxidation and reduction, we have seen the different kinds of definitions and some examples. Okay. So we will continue these reactions, oxidation and reduction reactions in detail in the next session.